This short video will demonstrate the operation and application of the model FM-140XL digital conductivity test instrument manufactured by Centurion NDT. Electrical conductivity is a property unique to a particular alloy. Knowing this value enables one to quickly and reliably identify an alloy or heat treat condition. It is very important in the fabrication of aluminum components used in the aviation industry. Without getting bogged down in theory, we use the eddy current principle to measure conductivity. The sensor, or eddy current probe, is a coil of wire excited by an AC signal at a particular frequency. When the probe comes in contact with the metal surface, a secondary field is induced in the material. This is called an eddy current field. The ability of the electrons to flow in the material is then compared to known materials with known conductivity values. This information is processed within the instrument and a value in % IACS is displayed. The model FM-140XL conductivity test instrument is an eddy current instrument specifically designed to determine the conductivity values of non-ferrous materials. The instrument is calibrated utilizing the two reference samples mounted on top of the instrument. Once this is accomplished, the probe is placed on the unknown material and the value in % IACS is displayed on the instrument. Now, let us see how this is done. The FM-140 is battery operated, so the batteries should have a full charge on them. Make sure that the probe is attached to the front panel and press the on button on the front panel. A beep is heard and the display shows Set Cal, and the red LED will light indicating that the instrument is on. Press the battery test button. The display should read higher than 12.5. A full charge will read 13.5 to 14. Now press the low push button. The amber LED lights and the display goes blank. Place the probe on the low sample mounted on top of the instrument. Using the up and down arrow, set the display to the same value assigned to the low sample, in this case 10.5. Press the high push button and the amber LED lights. Place the probe on the high sample and using the up and down arrows again, set the display for a reading of the high sample, 99.2. Repeat this process until the instrument reads the correct high and low values of the samples. Whichever push button was pressed last must be pressed again such that neither amber LED remains lit. You are now ready to test unknown materials. To set the gate, press the on push button and then the set. To set the low limit, press the low push button. Use the up and down arrows to set the value of the lower limit. Pressing the high push button will enable you to set the upper limit. When finished, press the set push button. The on LED will remain lit. Now when the probe is placed on a sample within the range set, the green LED will light. Conversely, when the value is set outside the range, the red LED will light. Now that the FM-140XL is set up, you can use it to determine conductivity values for your particular application. Many times the specification will specify the expected value. There will always be a tolerance associated with these values, whether it's the raw material or after a heat treatment. Centurion NDT can supply NIST traceable conductivity standards. These are typically housed in a 3-standard set and are required by many aerospace specifications. These are copper tubing samples. Sometimes the best way to get accurate readings is to flatten the item. There is a risk, however, that the part could be work hardened. Conductivity readings are taken on aircraft wheels to inspect for heat damage. Now that the instrument is up and running, it is designed to perform accurately and reliably for a long time. However, there may be instances where the instrument may not appear to be working properly. I will address the more common questions our customers have posed to us in the past. The first is regarding an 18.9 reading when the battery push button is pushed. This means that there is an issue with the batteries. 18.9 means that there is insufficient charge to operate the instrument. Charge the unit overnight and test again. If the reading is still 18.9, then the batteries will have to be replaced because they will no longer accept a charge. This happens most often when the instrument is plugged in for an extended period of time and not allowed to occasionally discharge. There may be instances when attempting the initial setup that the display is either blinking 10 on the low end or 110 on the high end, and it seems like the arrows have no effect. The easiest way to get the instrument back into range is to do the following. Press the push buttons in this order: low, high, high, reset. 4 bars will light up on the display. What this does is set the instrument back to a default condition so that the initial setup can be accomplished more easily. Then simply calibrate as usual. On rare occasion, the instrument may appear hung up and none of the push buttons seem to have any effect. This happens when the batteries are very low and the instrument is turned on. There is enough energy to start the microprocessor, but not enough to complete the startup sequence. To remedy this, there is a small reset push button accessible from the rear of the instrument. With a pen or pencil, depress the push button switch. This action resets the microprocessor by disconnecting the battery. Charge up the instrument for a few hours and calibrate as normal. Just a bit about the probe. The probe is designed to be placed on the part. Scanning a part should never be done. Scanning a part will also lead to premature probe wear and inaccurate calibrations. Metallic particles may become embedded in the front face of the probe, and this could cause inaccurate readings also. The front face may be cleaned with isopropyl alcohol. Probes are not interchangeable. In order to meet the accuracy requirements, the probe is calibrated with the instrument and must remain with that instrument. This is also spelled out in several conductivity specifications. This concludes the video demonstration of the operation of the model FM-140XL digital conductivity test instrument. I hope you found this helpful and informative. For further information on this product or any of the other fine products manufactured by Centurion NDT, visit our website at www.centurionNDT.com.